Hey, hi, this is Sundar from Vision Academy. Today my lecture will be on mathematical formulation of transportation problem. This is a lecture 2 series in transportation problem. Let us understand what is mathematical formulation in simple word. It refers to the translating the real world problem into the form of mathematical equation. Suppose you want to apply tools of operation research to a real world problem, it must be in a mathematical equation. Then only you can apply the tools available in operation research. Otherwise, you cannot apply. So it usually requires a thorough understanding of the problem, which I will try to make easy for you guys. If you are not yet subscribed to my Vision Academy YouTube channel, please do subscribe. Look at this tabulation. This is the desirable form to apply transportation problem. Observe here there are some things: destinations, availability or capacity, origin, requirements. So origins are O11, O2, OI, OM. Destinations are D1, D2, DZ, DN. Available capacity are A1, A2, AI, AM. Requirements are demand are B1, B2, BJ, BL. Suppose a manufacturer of item has M origins. M origins. Origins means plant, factories situated at places O1, O2, OI and OM. Suppose there are N destinations. N destinations. Destination means warehouses, distribution center at D1, destination 1, D2, destination 2, DJ and DN. The aggregate of the capacity of all M origins is assumed to be equal to the aggregate of all requirements of a N destination. Aggregate of all N destination. So it means the available capacity and requirement must be equal. So this is summation mi is equal to 1 ai is origin, that is available capacity, and summation nj is equal to 1 pj is requirement, demand from the destinations. It must be equal or assumed to be equal, then only you will find the feasible solution for your transportation problem. And now let's understand what is this C. C11, C12, C1J, C1N, etc. C is cost. Very simple, in a very simple word, it's a cost. Cost of what? See, look at here, C11. It's a cost of transporting from origin 1 to destination 1. So origin 1 to destination 1. So C 1 is I, and this one is J. So O1, D1. So this is the cost to transport goods from origin 1 to destination 1. Let us look at this example. C12. This is the cost to transport goods from origin 1 to destination 2. And C1J, C1N. And so on. This is a cost usually. Let us have another example for this. O2. This is a cost to transport goods from origin 2 to destination 1. This is the cost to transport goods from origin 2 to destination 2, and so on. These are cost usually we will mention and will be given in the problem. Look at a problem for which we can make a mathematical formulation. Milk in a milk shed area is collected on 3 routes, A, B and C. 3 routes, A, B and C. These are routes. And there are 4 chilling center, D, E, F and G. Chilling center, D, E, F and G. These are chilling center, and where milk is kept before transporting it to a milk plant. So these routes are origin in this case, and chilling center, this is storage area, DEFG as storage area. So this is a destination. Destination are DEFG, routes are A, B, C. Each route is able to supply an average of 1000 liters of milk per day. Each route, A route, B and C, having an average capacity of supply 1000 liter milk per day. The supply of milk on routes A, B and C are as follows. The supply of route from A route, milk is 160,000 liter, and B route is 150,000 liter, and C is 190,000 liter respectively. Daily capacity in 1000 liters of chilling center. This chilling center destination's capacity is 80 for D destination having requirement of 80, and E destination having requirement of 90. F destination having requirement of 110, and G destination having requirement of 220 respectively. The cost of transporting 1000 liter of milk from each route to each chilling center. Route is sources, it means origin. Chilling center or destination, as I said you already, differs according to the distance. So these costs of routes to destination have given. As I said you, C is cost. These costs are shown in the following. So cost of transporting route A to D destination is 42. Cost of transporting from route A to E destination is 48. Cost of transporting from C route to D destination is 39, and so on. So for the given problem, perform a mathematical formulation. So we have to perform a mathematical formulation for this problem. Friends, as you know all, in the mathematical formulation, there will be three properties. Those three properties are mandatory to make a mathematical formulation. You better to keep in your mind. First one is objective function. There must be objective function to optimize the decision. And second one is subject to constraints. And third one is non-negatives. These three properties are very essential in mathematical formulation. So for the given example, I am going to make a mathematical formulation. Before that, a linear programming, a transportation problem can be formulated as linear programming problem. To illustrate this, let us see how this example works here. Let Xij represent the quantity transported from ith route to j chilling center. Let Xij represent the quantity transported from ith route to j chilling center, and let Cij represent the cost of transported 1000 of liters of milk from ith route to jth chilling center in this example. So for this we have to make a mathematical formulation. There are these are decision variable. You want to make a optimum solution. You want to give optimum solution for this. These are decision variable, and in this case these are decision variable. Costs are decision variable. In this case there are 12 decision variable in the given problem. For A source 1 2 3 4 4, for B 4, C 4. So 4 into 3 12, and for D chilling center D 1 2 3 3, E 3, F 3, G 3. So 4 into 3 12 decisions variable. The objective is to find the values of Xij. In this case the objective is to find the value of Xij and Cij so as to minimize the transportation problem. So as I said you already, there will be three properties in mathematical formulation. First I will go for formulate objective function. The formula for formulating objective function is Z is equal to, here there are two types of constraints. One is chilling center constraint, another one is roots constraints. In the roots constraints, there are three again sub constraints. In the chilling center constraints, there are again four sub constraints. So Cij, Xij. So that's why I have taken two summation here, because there are two types of constraints: chilling center, root centers, root sources, and Z is equal to M is origin, as you know already. M is origin, and N, this is destination, and for that each I think I am going to formulate a mathematical formulation. So Z is equal to, as you know already, I comes under where? Origin, and J comes under destination. So for two chilling center and milk shed, I am going to formulate separate formulation. So Z is equal to summation M I is equal to 1, summation N J is equal to 1, Cij Xij. Z must be summation of all these things will be the objective function. So this is a minimization type, this is not a maximization type. Whatever, if the problem given in maximization type in transportation problem, you must convert that into minimization type. So here you are going to minimize the cost, so minimization, Z is equal to minimization. And look at here, Cij, here C1 X1, I told you C1 X1. So for everything Cij Xij, Cij means the cost of transporting I through to jth destination, and Xij is also same, the cost of transporting I through to jth destination. So the cost of, this is I, this is J, the cost of transporting I through to jth destination. So C1 X1, Cij Xij. So for both constraint, I am making two variables, Cij Xij. So the C11 means this, I can consider this as C1 A1 D1. So as well as X1. So see A1 D1, and if you come to second thing, C12 X12, this is A, this is this thing, I think this it should be this A C1 X2. It means the cost of transporting I through first route to second destination, E destination, A route to E destination, and C13 X13, 1 to F, A1 to F. This is C1, this is 3, so 1 3, and C14 X14, so C1 1 to 4, this is 4. So cost of transporting A route to G destination, it means the cost of transporting A route to A means sources 1, route to destination G, it means G is 4. So this is about first constraint. As you know, for A you have formulated as C11 X1, C12 X12, C13 X13, C14 X14. So there are three sources variable, there are three sources variable and four constraints. So for that, C11 X1, the whole thing is 1, C12 X1, the whole thing is 2, C13 X13, whole thing is 3, C14 X14. It means from A route to first destination, from A route to second destination, from A route to third destination, from A route to fourth destination. So there are four pluses, 1 2 3 4. Now let us come to the second source. Second source is B. Here from B is 2 in this case, B B is 2 in this case. B 2 2 1 2 2 2 3 2 4. Look at here. C is 2 1 x 2 1. As I said you 2 and destination 1 2 destination 2 2 1 x 1 2 destination 2 and 2 sources to destination 3 sources to destination 4. Observe very carefully. And let us go for third sources, third root source. It is 3. It must be then 3 1 3 2 3 3 3 4. Look at here. 3 1 3 1 C 3 1 x 3 1 C 3 2 x 3 2 C 3 3 x 3 3 and C 3 4 x 3 4. So here there are Cij Xij. For Cij, I means source, J means destination. So we have two sub constraint. One is shed, one is milk shed, another one is chilling center. For each thing we have indicated in mathematically C and X. So for each thing, this is source, this is destination. It means in the first constraint of source, source 1 to destination 1, source 1 to destination 2, source 1 to destination 3, source 1 to destination 4, and source 2 to destination 1, source 2 to destination 2, source 2 to destination 3, source 2 to destination 4, as well as source 3 means C, sources 3, source 3 to destination 1, destination 1 means D, source 3 to 3 means C, destination 2 means E, source 3 to 3 means C, destination sources 3, destination 3 means F, source 3 means C, destination 4 means F, G, destination C, 3 is C, 4 is G. So it is very simple. A to D means 1 1, A to E means 1 2, A to F means 1 3, A to G means 1 4, and B to D is 2 1, B to E is 2 2, B to F is 2 3, B to G is 2 4, as well as C to D is 3 1, C to E is 3 2, C to F is 3 3, C to G is 3 4. That's very simple as it is. And this is about objective function, mathematical formulation for objective function. And now look into the another property in mathematical formulation, that is subject to constraint. This is very important in mathematical formulation. We use this formula for subject to constraint. Summation mi is equal to 1x 1i equal to a1. A1 is capacity from source 1, and m and I is for we use in origin. And here, as you seen, there are two constraints in this case. One is chilling center and roots. For each constraint there are another sub constraints also. Example, for chilling center there are 4 constraints, sub 4 constraint. For roots there are 3 sub constraints. The supply of milk on route ABC and daily capacity in 1000 liters of chilling center DEFG impose itself constraints. As I said to you, the total quantity transported from route A, must be equal to its capacity of 160,000 liters of milk. Thus, for route A, we can formulate constraint like this. So x1, x11, x12, x13, x14. It means x11, x12, x13, x14 equal to 160. Look at here, x11, it means from route A to destination 1, x12 from route A to chilling center 2, it means 1 2 2 1 2 2, and x13 from route A to chilling center 3, and x14 from route A to chilling center 4. 4 means G. So these are equal to total capacity of sources route A 160, that's 160. So this is for first subject to constraint, and let us look into another second subject to constraint in routes. We have formulated subject to constraint for A of source origin, and now we have to formulate for B. So same thing as we formulated A for A, and route B is to the transport of goods from route B to D. It means B second constraint 2 D 1 2 1 2 2 2 3 2 4 2 1 route B to destination 1. It means B to D 1, and B to E2 in the given example, and B x23 B is 2 and 3 is F, and x24 B is 2 and G is 4. It is equal to 150, a total capacity of 150. For B is total capacity is 150. So x 21 22 23 24. And now let us look into another constraint in milk shed. So that's a third constraint. So third constraint, we can codify it as 3 3 1 3 2 3 3 3 4. So transport of goods from C to D is 3 1. Transport of goods from C to E is 3 2. Transportation of goods from C to F is 3 2 3 3. Transportation of goods from C to G is 3 4. That's what I have done here. 3 1 3 2 3 3 and 3 4. These the total capacity in C is 190. So subject to constraint, we have formulated subject to constraint for milk shed. Similarly, we must satisfy the demand for each of the 4 chilling center. The units can be transported through route A, B and C. Thus, for chilling center D, the constraint will be like this. So formula nothing change, just I have converted into chilling center. Earlier I had taken for milk shed. The formula is like this. So x11 I will tell you how it works. x11, it means from route A to destination 1, x11, and x21 means from route B to destination 1, x21. Earlier x11, x21, and now x31 from route C to destination 1. Look at here, x11 from route A to destination 1, x21 from route B to destination 1, x31 from route C to destination 1, and the total capacity, the total requirement of what destination D is 80. Total capacity of the requirement of destination D is 80. So route A to destination 1, route B to destination 1, route C to destination 1. It means 1 1 2 1 3 1. And same way to chilling center E, F, G. It means 1 2 2 2 3 2. Let us look into that. x12, it means from sources A to chilling center E 12, x22 from sources B to chilling center E, x32 from sources C to chilling center B, and total capacity requirement from chilling center E is 90. And for another constraint, that f, for f, from route A1 to chilling center 1, from route 3, from route 1 to chilling center 3, from route 2 to chilling center 3, f, 3 means f, from route 3 to chilling center 3. Look at here, 1 3 2 3 3 3. It means 1 3 A to EF, B to F, C to F. Total requirement in F chilling center is 110. And last, let us look into last G constraint. It means A to G. A is 1, G is 4. B to G. A is B is 2, 4 is G. And C to G. C 3, G 4. And total requirement in G chilling center is 220. And we are into last property of mathematical formulation, that is non-negative. Finally, all values of xij must be greater than or equal to 0, not lesser than or equal to 0. Xij must be greater than or equal to 0, as negative units can't be transported. We can't transport nothing, so there must be something to transport. So we impose, in mathematical formulation, we impose that there should be some production, there should be some transportation. So that is non-negative. For I means origin, 1 2 3 is greater than or equal to 0, and for j is a destination, that j is equal to 1 2 3 4 is greater than or equal to 0. The final result of mathematical formulation for the given problem is this. So which include property of objective function, subjective constraints, and non-negative. So we have done it in earlier only. So this is objective function and subjective constraint. For supply constraint, it means origin, demand constraint, that means destination, that chilling center, and this is a non-negative. And after formulating objective function, subjective constraint, and non-negative, we have all data to fill over here. The final tabular form of mathematical formulation of transportation problem for this given information is, I have inserted casters which was given in the problem, and milkshed, the origin is milkshed, that's milkshed A, milkshed B, milkshed C, and chilling center D, E, F, G. So available capacity, it was A 1 2 3. So, and requirement B, it was B. And now look into the tabular form. So capacity of A route is 160, capacity of B route is 150, capacity of C route is 190. Let us mention here 160, 150, and 190. The total capacity 150, 150, 160, 310, and 190, 500. Total capacity availability or capacity is 500. And now let us look into chilling center requirement. Chilling center requirement is for D is 80, and E is 90, and F is 110, and for G is 210. Let's mention here. D is 80, E is 90, F is 110, and G is 210. So 80, 90, 170, 280, 300, 500. So total requirement and availability is same. As I said you, it's a balanced transportation problem, and you can have a feasible solution for the given information. Thank you, friend. It was a huge video which you should afford actually, because due to lengthy of calculation, mathematical formulation, understanding, and all, I try to make it very easy. Please go through this And if you are not yet subscribed to my channel, please do subscribe to my channel.